state is actually a translation operator. So the answer is x plus a by 2. You can see that there is a translation of a by 2. This is pretty much simple. You are given a wave function, you just need to calculate the average kinetic energy of the system, of the wave function, of course. This problem is actually you need a rigorous calculation. Okay, so that first patiently derive the first derivative and then the second derivative, and then just write down in terms of the wave function, that is psi x. You will end up this. And now the integration. Now you will end up this result. These two, but this integration will be because it is odd function, this should be 0. After calculating using, of course, gamma function, you will get this result. Try it. You just need patience. A smartphone emits electromagnetic radiation with power of 1 watt. What is the approximate value of RMS magnetic field at a distance 25 centimeter from the phone? So as you know, S average, pointing energy average, is E RMS into H RMS, and S average also this E RMS square by mu naught, and B is equal to E by C. Putting all this formula together, and S average is P by 4 pi r square here, and the P is given by 1 and the R is given by 25 by 100 square. You get this answer 7.3, which is in the order of 10 to the minus 7 Tesla. Again, for this configuration, you just need to calculate the microstates. Okay, so every state can be occupied in 2 to the power n minus 1 way. There are 3 states, so total microstates would be 3 into 2 to the power n minus 1. Now the entropy is KLN omega, that means microstates. So this is the result. Okay, so if you wonder how it's 2 to the power n minus 1, you can check it by just, if you wonder how we get this, you just consider using 3 states. Okay, you can consider it. You will see that for every state can be occupied in 2 to the power minus 1, 2 to the power n minus 1 way. You can check it. That means by you just need 3 states. Just calculate, for example, you get under the expression why it's 2 to the power n minus 1, because also there is a constraint here, and the constraint is the system has a constraint that the neighboring spins cannot be in the same state. That reduces the one possibility, that means n minus 1 actually, otherwise it would be 2 to the power n. A particular counting system has an average background rate of 50 counts per minute. A decaying radioscope source has introduced, and the total 160 counts were measured in 1 minute. After a delay of 24 hours, the system measured total 91 counts in 1 minute. If these measurements were used for determining the half-life tau of the source, and if the average background rate, the time have no errors, the percentage error in the calculated half-life value due to counting statistics would be. Okay, now the average background rate is 50 counts per minute. The first count is 168, the actual count 168 minus 50, there is 118, and the error is 1 over root over 118. Second count, similarly, we will get the error 1 over root over 41. So the total error is this, the percentage error would be 14.3%. This is the formula. Question number 11, I think this is very rigorous calculation. You need rigorous calculation for this. I think I have not solved it. You guys can check Griffith there is it is given there. You can check it. Now, oxygen nuclei Z is equal to 8 can be approximated in non-interacting protons and neutrons filling of orbitals in the following order. Now, given the energy of O15, O16, O17, what is the difference of the energy? 1p of 12 and d 5/2 orbitals. First, O16 configuration. This should be the 16 configuration. You fill up proton and neutron. This is the filling up the orbitals. You will get this configuration, proton and neutron. And then 15, O15. Proton configuration will be same as O16, but the neutron will be, there is one less than the 16. This means p of 12. There is one neutron extra. There will be a vacancy of the electron in p of 1/2 orbital on half. And O17 is same, proton configuration same as O15, and the neutron configuration will be, there is one extra neutron in the orbital of d of 5/2. To get the energy of the orbitals, you just need to, for the d 5/2 orbital, you just need to subtract the energy of 17 and 16, and the for energy of p of 1/2, you just need to 16 subtract the energy from 16 and the energy of 15. You get 15.66, and so the difference between those orbitals is 11.56 mega electron volt. Consider the universe is always expands with a scale factor a that increases with time of as a of t is c to the power c into the power 2/3, where c is constant. Is expansion rate at time t is defined by the Hubble parameter. This is the parameter given, and the current value of ht universe is given, and what is the approximate age of the universe. So just you get the Hubble parameter in terms of time. That means h of t is 2/3 into 1/t, and you get the time there, and putting the value, current value, and converting it into meter, you get the time in second, and then you convert it in the years. You get 1.5 10 to the 9 years, billion years actually, in order of billion years. The age of the universe is in order of 10 to the 9 years. An X-ray of wavelength 3.1 angstrom incident on the 110 plane of a cubic lattice with lattice constant A produces a second order Bragg reflection at theta is equal to 30, measured from normal A to the plane. So now just theta, careful, this theta is given along the vertical axis. You need to calculate the actual theta is for our back diffraction. The theta is 90 minus theta, that means 60 degree, and then that pretty much simple. Now from there it's pretty much straightforward. 2d sin theta is equal to n lambda. You just put all the value there, and we will get the answer is equal to 5.06 angstrom. This is question 15. Okay, so we just need to apply all the conservation rule: charge, strangeness number, spin. And you can see that first one is possible, C number is possible by electromagnetic interaction, and the D is possible, allowed also, but the last one, the A, option A is not allowed, cannot be possible, of course, because of conservation rules also. Okay guys, thank you so much. There's two problems. One of the problems which is given in the Griffith book. You can check it there, and thank you. If there is any mistake, please let me know, because this is my first time. Thank you so much guys. Keep solving.